What's going on YouTube? Just helping you out here. And for today's video, I will be doing Chapter 16, Problem 2 in the Fundamentals of Physics textbook by Gerald Walker, Halliday, and Resnick. And Chapter 16 is all about waves. And in this particular problem, we are told that a sand scorpion is trying to detect a beetle that is some distance away using two different types of waves, and the change in time between the waves is how the scorpion will detect the distance. And we are asked to find that distance. So we're going to start with the fundamental equation: velocity equals distance over time. And we can rearrange that for the distance by saying distance equals velocity times time. Now the issue is that we have two different types of waves, so we need to write two different variations of this. So distance equals velocity of transverse, or t. I'm just going to start saying t, and L for longitudinal because it's going to get annoying to say those words every time. So Vt times Tt equals Vl times Tl. And so what I want to do now is make a ratio of the times on one side and the velocity on the other. So we can write Tt over TL equals VL over VT. That was just rearranging this equation up here. So you divide by TL on both sides, and then divide by VT on both sides to get this. And so when we fill in our velocities, we get 3. So the ratio between the time of t and the time of L is 3. So that means that the time of one transverse wave is 3 times that of longitudinal, which we can see here. 3 times 50 is 150. So we can write time t equals 3 time L. And also in the problem we were given that the change in time is equal to 4 milliseconds. So we can write the change in time is equal to the time for t minus the time for L. And since we just found this up here, we can plug that back into here. And that'll give us 3TL minus TL. And the reason I did that is because these times are now the same and I can combine them. So that's going to equal 2TL. And that's still equal to the change in time, which we were given is 4 milliseconds. So we can say 2TL is equal to 4 times 10 to the negative third seconds. That's just milliseconds written, 4 milliseconds written in scientific notation with the unit seconds. So if we divide by 2 on both sides, we find that the time of L is equal to 2 times 10 to the negative third seconds. And now that we have the time, we can solve for our distance. So distance equals velocity L times time L, which is equal to 150 meters per second, times our time, which we just found is 2 times 10 to the negative third seconds. And that should equal 0.3 meters or 30 centimeters. And the reason we can use this is because it is also equal to the transverse version, and which are both equal to the distance. So you could use either one, but I find that one to be the easiest. So that's it for this problem. If you found it helpful, please drop a like, leave a comment if you have a question about something I did or an idea for a future video. And lastly, please do not forget to subscribe. I'm just helping you out. See you in the next video.